I'm Vietnamese, but I feel like we still have some English speaker here, so it's better to speak in English. So we start with English, but it's okay, right? Okay, let's start. Thank you everyone to attending here. I know this last session, so everyone feel tired, but yeah, let's just start. And I'm be sure that this is just not full information, but just very, very lively and kind of showing things. Okay, so let's just start. I'm Khang. I'm a software engineer at cyber agent, and I'm the maintainer of the 5C mosaics. And I do GitHub and Twitter. And my talk is about 5CD, but before we just start, I just had a little bit share about the challenge of the deployment on multi-cluster and multi-cloud environments. So I'm listing here is some problem we face when we do CI/CD for the company-wide. I'm from the CI/CD platform team, and the first one I get here is different cloud, different tools. What I mean cloud here is, say for instance, is Kubernetes, iOS, GCP, for iOS maybe it's Lambda, ECS or something, anything we containerized. For GCP we have runs, things like that. And if you have experience of working on some kind of environment that missing in between many things like it, or maybe it's not just your team, but for your whole organization, different teams have different way to choose the platform, and you definitely face with problem like this. And the point is, for Kubernetes, we have some kind of community standard like ROCD, FOSSASIA, but for the other, what do we have? We do not have any standard like that. And the next one is about the securities and observability. I know that most of people, most of the company and most of team do use CI for CDs, which means that we have to set credential to the CIs. What we actually believe is we should separate the CI with the CD. The CI should focus only on the testing and building the artifacts, and the CD should be the one who take the rest from the artifacts to the cluster deployments. So it could be lead to some serious security issues if we mess up. Actually use one for everything. That's why I laid it as the second point. And the third is, how do we do progressive deliveries to multi-clouds? For here I have a new word. Not actually new, but pretty new if you do not actually work as a CI/CD engineer. Is progressive deliveries. We know about the GitOps, we know about the continuous deliveries, which is CD, but for the PE, progressive deliveries, is kind of term of using some strategies to deploy the application. If you hear about the canaries, you hear about blue-green release, that is talking about progressive deliveries. You not actually fully deploy the application at once. You have canaries version, you test it with your user, and if everything is okay, then you go next, release everything. Or if you get any problem, you roll back automatically. That kind of simple immersion about the progressive deliveries. So what do we have as a solution for everything? I'm not sure you guys have the same immersion with me, but the first thing that comes to my mind if I have to do support multi-application kind, multi-cloud, is the same thing. I know it's still the standard for the community and for the market, because I actually did that I enjoy some conference in China and in America as well, and I asked this question: what do you use as the CD for your application for the system? And the point is, I'm having here is Jenkins and other, which is actually the CI with CD works. So basically, the half of the answer is CI with CD things, and the other half is we have everything on the Kubernetes that were pretty nice. So we use everything on Kubernetes, and we have Argo or CD for that. And just a little bit mentioned here is the Argo really strong compared to the Kubernetes. And so what is the fulcrum? If the CD does the CI job, then it can lead to some kind of serious security issues. For Jenkins, you may hear a lot from the community is the performance issues. Basically, the Jenkins does not exist from the time when the cloud natives grow this much, so it's kind of understandable. And on the opposite side, we only have standard CD for the Kubernetes, so we have to do, for the other kind of application, like I just said before, serverless thing like Lambda, Cloud Runs, or Terraform, something like that. ECS, you have to have ton of script that running on Jenkins or some CI like GitHub Action, and it's costly to maintain that much of a script across different cloud and different application kind. So it is the gap of the market, and we think that and we feel that. Not just feel, but we have experience on maintaining that kind of complex CI/CD for the whole company-wise. After this, I will send you a little bit more about that later. But we start this 5 CD projects as a team projects, and the vision of 5 CD is the 1 CD for all. And we want to mention here is we are CD. We focusing only on the CD. CI probably we can use just combat CIs or open or early pipelines, just as previous one. But for the CD, we want to make this 5 CD as the 1 CD for all. It's designed to overcome the challenge across our experience of various applications to various kind of platform and different cloud, and it has to be work easily and smoothly across a scalable organization. And a little bit of information to say about 5 CD. It's the in-house style CD tool, and it takes multiple app and multiple provider as the first citizen, and it's work well with it's fit for the larger scale organization, but it's work well with the similar project as well. And its current status is the CNCF Sandbox projects. If you not know about CNCF, it's the Linux Foundation sub foundation, and it's fully open source. Currently, we passed 3,700 commit already, and we have about nearly 80 contributors worldwide, and we're on the way to get our first 1,000 stars. So if you like, please support us. And interesting thing here is they support in the contributor list, and also we have some former PTIT student as the contributor currently as well. They know me, and I invited you. Invited them to be the contributors. Let's see. Next would be the PyCD at a glance. I will guide you some feature of PyCD and some retrospective of the projects. First, as I said before, PyCD is support the range of applications. We currently support the Kubernetes, the AWS ECN, Lambda, the GCP Cloud Run, and the Terraform. and it is this, what can I say, the simple of what you need to actually use the FOSSASIA in action. We have here is the Kubernetes application manifest. We have deployment, we have service, and the smallest setup, and we need to prepare FOSSASIA configuration journal. And this kind of thing like this basically is define the pipeline of what actually is going, and a pipeline is set of state that we predefine was customizable for application guy, and we have some kind of common state as well. You can actually mix it with the application guys, so build up your pipeline, and this is what you get with this kind of pipelines. And the nice point is it's work not just for Kubernetes but the other application platform as well. And it is simple for the cloud runs. We see here is the same things. We have service of Jumbo, which is the setup manifest for the GCP cloud run, and we have the pipeline definition Jumbo, and we get this one pretty same. And next retrospective is FOSSASIA integrates with the Kubernetes ecosystem easily. FOSSASIA work well with customized ham on Istio if you know whatever from here. And next thing I'm showing you here is the simple UI for the deployment details of FOSSASIA. We have here is the pipeline I just showed you before. It's compiled of 4 different states, and we have state load and clicking around right here. This one is application detail based, where I want to talk a little bit about this one. This one is drift detection feature of FOSSASIA. It's compare the manifest and the in-cluster state, and if you find any different, it's showing here, and you can trigger the recycle of your application from here. Basically, FOSSASIA work, we have 4 kind of trigger, which is on the chain, on diff detection, on when you click on chains. I will talk about on-chain trigger later. Next is the overview of the FOSSASIA architecture. This is the reason why FOSSASIA, I said, is work well with the large-scale organization, as well as working well with the simple project as well. You see here that FOSSASIA combined from 2 components, one centralized control plane, and many we call it an agent. So in a simple case, the platform team, I mean the whole companies only need to have one centralized control plane, and basically the CI/CD team or the platform team will operating this control plane, and it's a stateful component, while the agent is state component. Every work team, developer team can install it inside that cluster, and it's just a single binary. It can be installed anywhere, and we test it running as a Kubernetes pod, or just in the VM as a process, or as a serverless handler. Anything, it just work well. And when we talk about scale, we have one centralized control plane that actually the platform team need to care about. Why the company-wide scaling? We have new team, we have new project, we have new cluster. Just use that agent to that cluster, that all, and everything working well, at least in our case. And if you are platform engineer team who maintain the CI/CD for the whole companies, your job is install the control plane and operating is. I can say that it's much less work compared to my previous experience when I have to maintain the whole Jenkins thing. Also with the was updating. You know, if you use Kubernetes and you use Argo, when you update your Kubernetes cluster, you have to ensure that the Argo is still working on that. Or vice versa, when you update Argo, you have to ensure that your current Kubernetes cluster is still working. Something like that. For ByCD, platform team has to maintain the control plane only, and it's basically a Kubernetes application, but it's well containerized, so you can actually install each of these components as well. But it's recommended to just using hand install command, and everything will go up. And it's even easier when you look closely. We have 5 components inside the control plane, but this tool is the cloud provided managed service, which is say this one can be RDS, just RDS, or Cloud SQL from GCP, Aurora from iOS, or whatever else. I mean, it supports currently MySQL and file store from GCP, and the file store is just iOS S3 or GCP GCS, and I mean it's cloud provided managed service, so it's not you really have to be care about that. And one install is just a simple Redis instance, so it can up and down, but yeah, it's not affect your company's CI/CD platform, so you don't have to worry about that much. And if you are the developer or production engineering team, the thing you have to care about is even easier. You have to you just need to install that agent, and you prepare that pipeline aside with your manifest, then that will actually will take the rest. Of course, you still have to do the development work, so the good point is you can focus on that. And also the agent, every management feature can be you can interact with the agent via the ByCD UI, so you not actually have to all the time touching the cluster or something is not good. So we know that, and we make that as easy as clicking something on the UI. Okay, so next I want to talk a little bit about the security retrospective of the ByCD. I just talked previously about why we should not use the CI to do the CD work or pipeline commonly for every CD task, because if you do that, your pipeline CI has to create to access to your cluster, to your production cluster, and as a CI/CD platform engineering team, which means that there would be someone else not from your team understand the create or understand for say for instance when you have centric Jenkins for the whole company wise, that's Jenkins could get whatever create or just set to whatever cluster in your company, and it's quite I mean single point of fail or the point to attack if I'm the one who want to do something bad. So the ByCD architecture we avoid that by making the agent running in cluster. Your agent which has the creator to actually touch the application in the cluster, and also it has the way to connecting to the Git with pulling the application manifest, and that all control plane do not know anything about that cluster. Your creator is safe in your cluster, and that was the point, not leaking anywhere. Also, every request from the agent to the control plane is fully model. It's outbound request only, which means that the platform team who has maintaining the control planes do not need to know what and where your agent be installed. It's just the place of restoring the application state on deployment.org. So it's way safer. Also, PTIT has some security feature as well. We have a built-in security management. Basically, this one is templating feature that support you. You can store in your things, password or parental design with your manifest. And we have RBAC as well. I think it's fair enough for person ready things. Also for the SSO learning things. Okay, so next one is progressive risk. As I said before, progressive risk is about how to automatically deploy the new version to subset of your user and then evaluate any problems, any correctness, any performance issue before running it to the old user to reduce the effects. If you actually do kind of B2B or B2C service, you can understand what I mean, especially B2B. They really care about the uptime, the non-code, bug-free environment. So it is the thing that we should care about if we actually care about our user. And PTIT have this state with names analyst state. Basically, this state will perform some kind of prompt trials to canary roll out and actually testing something that you write down, and if anything wrong happens, this automatically trigger the rollback. And it's not only for Kubernetes but the other as well. Oh, sorry, I missed a slide. Okay, so internally the analyst state basically is the PTIT agent connect to some kind of metrics exporting service like parameters or Datadog, which is supported by PTIT, and it's perform the prompt queries, and we have kind of threshold or something like that. And if we find something wrong, then it's trigger the rollback. Yes. Next one is the deployment change feature of PTIT. We have here is kind of application finish, then trigger next application, then trigger next application deployments. Which I have here is simple use case where we have Terraform like as an IAC for your cluster. Then after this one is updated, then you update, you trigger the deployment for your Kubernetes application or cloud application at the same time, and then you trigger update for the next application. Is everything run on chain?